Fouettes are considered an advanced and complex dance move. They can be performed many different ways, but in this project we will be looking at them in a la seconde. This move can often be viewed as the pinnacle of dance. I would like to analyze this movement in order to teach and perform this complex skill more efficiently. During fouette turns, the gesture leg performs horizontal abduction and horizontal adduction simultaneously with the arms moving in the transverse plane. The gesture leg is externally rotated with plantar flexion of the foot. The supporting leg experiences flexion of the hip, knee, and ankle, and then extension of the hip, knee, and ankle. The entire body rotates clockwise around the longitudinal axis as the head rotates to the left and right while spotted. Fouette can be broken down into two phases. The first phase, shown here, can also be known as the preparation for the turn, while the dancer is in plie with the arms in first position. The second phase, shown here, shows the gesture leg extended to the side with the arms in second position. The second phase takes up almost 75% of the movement. However, the first phase is the most important as it sets up the success of the turn. There are many different biomechanical principles that come to play while performing fouettes: change in position, change in speed, acceleration, work, energy, power, torque, force, and inertia. Fouettes should be performed in a single location and not travel in any direction, showing no change in position. The displacement, if done correctly, should always be zero. It is also important to make sure displacement of individual body parts, especially the pelvis, does not happen, to ensure proper alignment for continuous spinning and constant verticality. The change in position of the arms from first to second position helps in the rotary factor of the turn. The fouette can be done on the right side or left side, turning inside or outside, clockwise or counterclockwise. However, once the dancer begins in any of those directions, they should continue in that direction until the move is complete. There is a change in speed during each rotation of a fouette caused by the swinging of the free leg laterally. Fouettes contain angular velocity, which is the speed in which an object spins. The angular velocity during the rotary phase of the turn should be larger than the stationary phase of the turn, which is why the dance move appears to be whipped, which is the literal translation for fouette. The goal is to have the same angular velocity at the beginning of each rotation. Because of this angular velocity, the fouettes have positive and negative acceleration in a constant direction towards the way the dancer chooses to rotate, usually to the right. The positive and negative acceleration corresponds to the change in velocity. The greater velocity, the greater the positive acceleration. There is also an upward acceleration of the whole body from phase 1 to phase 2 when the supporting legs moves from plie to releve. The point of the fouette is to see the isometric hold of the leg in second while the dancer rotates. This may be why fouettes appear to look effortless, but in reality are a very advanced skill. The majority of the time used to execute the skill has no work, energy, or power, which is why when any of these principles are used, it needs to be very effective. In theory, all three principles are vital for a fouette to take place. It is key to have just enough of each one to overcome the friction between the floor and the dancer's foot for one rotation, but not too much to throw off the balance and stability the dancer must have to give the fouette the desired quality of ease. By looking closely at these three principles, it has enlightened the fact that all the work, power, and energy takes place only 2 times during each rotation in a very short amount of time. Therefore, these principles must be efficient, effective, perfectly proportioned, practiced, and perfected. work can be seen in the transition from the first to second phase and the transition from the second phase back to the first phase. The first transition shows negative work because the displacement is moving upwards with an eccentric contraction of the muscles. The second transition, returning back to the starting point, consists of positive work because the displacement is downwards with a concentric contraction of the muscles. There is a moment of isometric contraction between these two transitions of work when the rotation is happening and the limbs are outstretched and stable. It is important to keep the overall net work at zero to ensure the fouette is correct and efficient. Energy is known as the capacity to do work, and this is especially important in completing multiple turns. Gravitational potential energy is key in the dancer's preparation before beginning the turn and in continuing the rotations. The more the dancer can find a deep, rounded demi-plie in preparation for the fouettes, the more potential energy they have for work and successful completion of the two phases. In between each rotation, the dancer returns to a demi-plie on the supporting foot, and the dancer must use it wisely to create more potential energy to keep the rotations going. Power is defined as the rate of doing work and brings time into play. When the fouette is divided up into the two sections, the transition into it and the transition out of the turn, we can begin to dissect the power needed to make the fouette happen. The two transitions where the work is present should be done quickly. In reality, the time should be below 1 second, while the work should be just enough force to displace the body upwards and downwards about 3 to 4 inches. During the turn, the dancer must actively use torque to continue to rotate. The working leg performs a whipping action in combination with the arms working from first to second position, creating a frictional torque from the floor. There is also a larger hip abductor torque in the supporting leg at the beginning of each rotation. Angular momentum of the arms and gesture leg is the key factor in completing the rotations. The net external torque needs to create enough momentum of these body parts to whip the entire body around. Perfecting the angular impulse is a useful tool when trying to perform multiple rotations. The torque is the answer to how to get around each time and create the whipping of the turn. Additionally, dancers create a torque before beginning the turn by using a wider fourth position or increased moment arm. In order to successfully perform fouettes, a dancer must initiate the turn with a perfect force couple. It is important to keep a constant position, and making sure that there are two forces that are equal in size but opposite in direction is key to not creating linear change. The moment of force is the amount of force causing an object to rotate. While executing this skill successfully, there is only one real moment to access force, which is why the dancer must use it wisely and get enough momentum to match the needed displacement to complete a rotation. This moment is the transition that starts and ends each rotation. Right before this moment, the entirety of the foot is on the floor, with an increased base of support. The supporting leg is in plie and the arms close to first position. The moment of force happens by quickly moving into phase 2, extending the leg to releve and opening the arms to second position to initiate the rotation. It is hopefully strong enough to send the body floating around while the legs and arms are outstretched isometrically. If the dancer misses this moment of force, they will not continue to turn. However, the most important moment of force is the one used to start the turns. This sets up how each of the following moments of force will be and if equilibrium is achieved. Manipulating the moment of inertia is important when turning. A dancer cannot change their mass, but they can change how their mass is distributed. The fouette is performed with the leg outstretched, but the dancer must organize themselves internally to turn more efficiently. This usually happens by binding the muscles, lifting up out of the pelvis, and creating internal force couples. Another vital part of the turn is the specificity of the phases. Each should be timed out perfectly so the main show is the turn itself. The dancer must figure out how to perfectly time the angular impulse to reinitiate the next turn front to the audience. This means the dancer cannot be intimidated by the decreased external torque and decreased momentum that will happen in the later half of the rotation. I hope that by watching this analysis of fouette turns, a deeper understanding and efficiency of the move can be achieved by teachers and dancers. This is an advanced bodyweight skill that can often be dangerous if not taught or performed correctly. A solid strength training program should be administered to train the supporting leg before attempting this move to ensure the safety of the hip, knee, and ankle. Thanks for watching.